Prachi is reminding us that electric motor is a device that converts electrical energy into mechanical energy. Yes, that is correct. If that is the meaning, if that is the simple definition of electric motor, what can you say about an electric generator? Very good, Khadija, very fast answer. So now electric generator will do the complete opposite. And as Khadija says, it is a device which converts mechanical energy into electric energy. Correct. And if you simplify it, it's a device that generates electricity. Generator, generate, to produce. Correct, Anushka? Electric generator is something that generates electricity, electric energy. It converts mechanical energy into electrical energy. See, so simple. That is why I did not include the slide for that. So what is the principle? How do we make it? It's the same Fleming's right-hand rule that we studied in the last class. It says, now we are working with our right hand. If we stretch the three fingers of our right hand, that is the thumb, the index, and the middle finger, in such a way that the index finger points in the direction of the magnetic field and the thumb points to the direction of motion of the conductor, then the middle finger shows us the direction of the current induced in the conductor. So middle finger comes last. First the magnetic field, then the motion of the conductor. So we have magnetic field. We move a conductor in the magnetic field to induce a current in the conductor. So here there is no the right hand side diagram that you see on the screen where just three arrows are there. It will be same. It will be same for both the Fleming's right hand rule and the left hand rule because the fingers are the same. There is no way you can figure out which is what, right? Just see if there is any difference between these two diagrams on page number 58 and page number 55. See if there is any difference. There is just one difference. Top is motion, the upward pointing arrow. The left and right arrows, those things are changed. So हमने left hand को ऐसे रखा, तो हमने left side को, right side को हमने कहा, in case of the left hand rule, this becomes the magnetic field. लेकिन जब हम right hand को हम use करते हैं, then this finger becomes the magnetic field. That's the only difference. So be careful. If the diagram has the entire hand, then it's very easy to find कि हम ये कौन सा हाथ है, उसको पकड़ना बहुत आसान हो जाता है. But if you are looking at a diagram which is there on the right hand side of the screen, then be very careful. It is a little difficult to identify whether it represents Fleming's right hand rule or left hand rule. Okay. You have told me what a generator is, and we have discussed how it may work. So how is it constructed? Okay. This is how it looks. Now you tell me, you look at the description that is starting on page number 59, bottom of the page number 59, and it continues till the end of the chapter, that is page number 60. You read it and you tell me what are the different parts of an electric generator. You tell me and I will include it on the slide. If you compare the construction if you compare the parts of a motor with the parts of the generator that you have listed now, there is one big difference and only one big difference. And that is in motor, we said split rings which were split in half. Here we are calling them conducting rings. They are not split rings. They are full rings, complete rings. Let us see how it works. So unlike what we did in the last class where I explained to you first and then we saw the video, let us look at the video first. I hope you were able to watch the video and listen to the explanation. So what is happening here is, and yes, it covered both AC and DC generator. Don't worry, we will understand it in a little bit more detail and in a language which is more convenient for us. Have patience. Before that, based on what you have watched in the video, do you think the diagram that is given in the textbook is correct, or do we need to make some changes in the diagram? Just like the diagram for the motor, which is given in our textbook, where the coil or the armature is connected to the brushes, and we discussed it cannot be connected to the brushes, it has to be connected to the rings. In case of the DC motor, we said it should be connected to the split rings. Same is the case here. The armature, the coil cannot be connected to the brushes, because the brushes are connected to the external wire. If the brushes are connected to the coil also, then the wires will get entangled. It is not possible. It will be a disaster. The coil has to be connected to the rings. And in this case, the rings are called rings, or there is another name for that. They are called slip rings, not split rings. Not split, they're not half. Slip, S-L-I-P, slip rings or just rings. And the basic difference between what we saw in case of a DC motor and what we are seeing in an AC motor is, in addition to the split ring, here we have two complete rings, and one arm of the coil is always connected to one ring and the another arm of the coil is always connected to the other. There is no exchange of arms, which happens in case of the DC construction. Right? So suppose we are moving this armature, this coil, in the clockwise direction. Clockwise means like the hands of the clock. So if we use our Fleming's right hand rule, our magnetic field is from north to south. We are moving clockwise, so the arm AB will move up. And because of that, the current that will be induced in the arm AB will be like going in to the screen, going away from you in the direction AB. And that current will flow through the coil from B1 to A to B to C to D to R1. This is what will happen. Now, when half the rotation is complete, and while this is happening, the complete opposite thing is happening on the other arm of the coil, which is arm CD. Now it is like this. Like this, it is moving down. That magnetic field is in the same direction. So now the current is towards us. So from C to T. लेकिन जब ये घूम कर पूरा, when AB goes in the place of CD and CD comes in the place of AB, now CD is going up. Now if CD is going up, again this will happen. Now the direction of the current will be from D to C. From D to C, that means from ring R2 to R1. In the first half of the circle, the current was from R1 to R2, ring 1 to ring 2. In the second half of the cycle, the current is from ring R2 to R1. पहले ऐसे गया, फिर ऐसे गया, alternating current. Because of this, the direction is repeatedly, periodically changing. Half of the time, it is R1 to R2. Half of the time, it is R2 to R1. And we are able to do this because of the way we have constructed. We don't have split rings. We have two complete rings, and the connection with the arm of the coil to the ring remains constant. Because of that, the direction changes. What we will observe in the galvanometer is for half of the cycle, the needle will move right. For the other half of the cycle, the needle will move left. Direction is changing. This movement will not happen if we use a direct current, if we generate a direct current. Very important point Shubham made unknowingly, right? When he said petrol or diesel. So in a typical generator that we use, the smaller ones at our homes or in the shops, it is the chemical energy of the fuel, diesel, which is converted through an engine into a mechanical energy. That mechanical energy is used to rotate the coil, and this rotation, because of electromagnetic induction, EMI, generates electrical energy. So chemical energy to mechanical energy to electrical energy. Let us now relook at both motor and generator with respect to AC and DC, alternating current and direct current. Remember, till now, we have looked at only one type of motor, which is DC motor, and we have looked at only one type of generator, which is the AC generator. What we are trying to do now is, we will try to think, how will a AC motor will look? What will it do? How will a DC generator look? What will it do? And I promise you, we can answer these questions with the information, with the limited information we have till now. It is enough. We have to think, we have to understand properly, and then we will be able to answer. This is what we have studied for motor. Direct current. Of course, the diagram is not accurate. The armature, the coil should have been connected to the split ring. And this motor works when we supply direct current to it. So this is called a DC motor. Motor is a device which converts electrical energy into mechanical energy. We have discussed in detail that across the world, we don't get direct current supply at home. We get only AC supply. Then how will this motor work? This motor can only work with a DC current. We don't have DC current, access to the DC current. We have alternating current. And here is the challenge. What changes do we need to do in this construction for this motor to work with alternating current? This is the challenge. Think. John, that for us to use the motor as a with alternating current, what we need to change is, instead of the split rings, we need the conducting rings, the full rings, the slip rings. And yes, he is right. We need one more change. Right? Now we do from two halves of the split ring, we need two full rings. We also need them to be separate. We also need the coil to be attached to one ring all the time. These are the changes. So how will it look? It will look just like a generator. It will look just like a AC generator. But instead of we getting the electricity, we will have to connect it to AC. Let's see what happens. Now, in the diagram, which is a diagram of a generator, imagine that instead of us checking what current is coming out, what is the direction of the current, suppose we are connecting power to it. So now look at the left hand side of the arm. We are trying to make it a motor. So Fleming's left hand rule. Suppose in the first cycle, that direction of the current is from R1 to R2. That is from B1 to A to B to C to D to B2. If that is the case, our magnetic field is like this. our current is going like this, then the motion, the arm will move in this direction. नीचे जाएगा. In the arm CD, it will be like this. वो ऊपर जाएगा. So our armature, the coil, will move in the anti-clockwise direction. Now, when the CD is at the point AB, remember we are giving alternating current. Now the current will be moving from R2 to R1. So when CD is at the point AB, the direction of the current changes because it is still connected to R2 to R1. And now it will start moving down. And it will keep on moving. AC motor. So if the construction of the rings, if the arrangement of the rings is like this, then the device will be an AC device. If the construction and the arrangement of the rings is like this, then it will be a DC device. Very important and very simple. Similarly, if we have to produce direct current, then we have to make similar changes in the AC generator. Instead of two conducting rings, we will have two split rings. The direction of the current will remain same. And then again, if we keep on moving the generator in the same direction, the direction of the current will remain same. So whenever it is DC that we want or DC that we are using, then the construction should be like this, split rings. If we need AC, then, or if we are using AC, then the construction should use full rings. This is one aspect, the difference between motor, generator, AC, DC, everything. The second thing is, how is a motor fundamentally different from a generator? In motor, we are taking the electric current and converting it into mechanical energy. In case of a generator, we are taking the mechanical energy and converting into electrical energy, right? So in terms of the diagram, the poles remain as it is, the armature remain as it is, the split rings remain as it is, the brushes, the axles remain as it is. The only difference in terms of the diagram, in terms of the usage between a motor and a generator is electric current is supplied to the motor. So we will show a battery or we will show a alternating current source. Whereas when we are drawing a diagram for a generator, we will show a galvanometer. कहने का मतलब क्या है? मतलब ये है that on the screen right now, on the left hand side we have a DC motor, on the right hand side we have a AC generator. मैं अगर बस इतना change करूं that on the left hand side, in the left hand side diagram, in place of the battery, if I put a galvanometer, then the diagram will become DC generator. In the right hand side diagram, in place of a galvanometer, if I show a AC source of power, then it will become a AC motor. Textbook में DC motor दिया है, AC generator दिया है, and it has asked us कि AC motor, how will it look, how will it work? It has asked us DC generator, how will it look, how will it work? And I'm telling you, all we need to do is make these changes. Use correct power source. use the correct arrangement of the split rings or the rings. Our diagrams are same. If the diagram on the screen is not clear, and it is not clear, look at page number 61 of your textbook. Question number 11, part C. Question number 11, part C. Look at the arrangement and tell me what is it. Look, when you are looking at the arrangement, the two main things that you will focus on are how are the rings arranged, and the second thing, are we supplying power or are we getting power? Look, think, tell. What is this diagram for? It's a DC generator. Karthik is also saying DC generator. How do we know whether it is generator or motor? We look at the bottom of the diagram. It shows a ammeter here. Instead of a galvanometer, it shows a ammeter. Ammeter also records current. We are not supplying current. We are measuring the current that is produced. Current is produced. That means diagram for generator. Right? So this is something related to DC. See, this is something related to generator. Clear? Now look at the rings. We don't have two full rings. We have split rings. Split rings means DC. So it's a DC generator. DC generator which produces direct current from mechanical energy. These are the two diagrams given in the textbook. The diagram on the left hand side is of a DC motor. The diagram on the right hand side is of a AC generator. So I asked you to draw these also. In addition, I asked you to draw the AC motor and DC generator. Now to draw the diagram for AC motor, all you have to do is start from the AC diagram. So AC diagram is on the right hand side. And in the diagram, instead of this galvanometer, we have to show a energy source, alternating energy. तो हम ऐसे एक circle बनाएंगे और ऐसे उसमें बना देंगे. Now what we have is a AC motor. We converted the AC generator diagram into a AC motor diagram by converting the galvanometer into a AC source. Right? So now we have the AC generator, AC motor, and we also have the DC motor. One thing remains, which is the DC generator. So for the DC generator, we will go to the DC diagram, DC construction, which is on the left hand side. But it is a motor. We have to convert that into a generator. So we will remove this power source. Right? Now we have to show a galvanometer. This is the symbol of galvanometer. We can also show a symbol of ammeter. Now what we have is a DC generator. So we can convert a AC generator into AC motor, and we can convert the diagram of a DC motor into DC generator. The diagrams with respect to the split rings and rings that tell us whether it's a AC diagram or a DC diagram, AC device or a DC device. And the diagrams with respect to whether we are supplying electricity or we are producing electricity, they tell us whether it is a motor or generator. So two things, two different combinations, so 4 outcomes. 4 different diagrams. So this will be your homework. We have completed all the theory of the chapter. So you will complete your notes and you will complete the remaining questions from the textbook exercise, which are 2B, 4, 5C, 10A, 11C, 1, and 7C. Question number 1 and 7C, we have not discussed specifically in the class, but I'm sure you will be able to think, write, research, write on your own. Before we finish, let us look at the entire chapter once again and then close the class. I will share the newspaper or I will share the textbook with you on the screen. We started by understanding, revising what electric current is. We revised how electric current we use in day-to-day life. We then looked at the maths of electric power and electrical energy, the different formulae, units of measurement. Then we studied about the heating effect of the electric current, what material the coil is made up of, what is the shape, size of the coil, all those things. We also understood how we make the electrical circuit safe by earth wire and also circuit breakers. The circuit breakers come in different shapes and sizes. Then we studied about the magnetic effect of electric current, where we understood that if a current carrying conductor is placed in a magnetic field, then it experiences a force. Right? And when electric current passes through a conductor, it creates a magnetic field. And because of that, when the current carrying conductor is kept in a magnetic field, it experiences a force. Like poles repel each other, unlike poles attract each other. The direction of the magnetic field is given by the right hand thumb rule. We understood how different conductors create different types of magnetic lines of forces, especially about solenoids. Solenoids act exactly like a bar magnet. And this force that the conductor experiences results in the motion of the conductor, and this is explained by Fleming's left hand rule. Using this principle, we understood how motors are constructed, how they work. And combining with today's class, we know how we can make both a DC motor as well as a AC motor. The motors that we use at our homes, they are AC motors, not DC motors. Then we studied about electromagnetic induction, where we studied that if the magnetic field changes, then it produces a current in the conductor, and that current can be detected using a galvanometer. Galvanometer is represented by a G, capital G. Ammeter is mainly used for measuring, and galvanometer is mainly used for detecting. And also again, yes, that much we will know for this year. We saw how the magnetic field can be changed by moving the conductor, by moving the magnet. Any of the movement can cause change in the magnetic field. And this change in the magnetic field produces a current, the direction of which is given by the Fleming's right hand rule. In today's class, we understood how that Fleming's right hand rule can be used to construct a AC generator. Also, we understood how the same thing can be used to construct a DC generator. We also studied in the previous class how AC is different from DC. We thought about why AC is used, and we understood that in case of AC, it is safer, it is cheaper, and there is lesser power loss. Now, when you try to complete the questions in the exercise, question number 1, as I said, you can answer on your own. Question number 2A, we had completed already. After today's lesson, you will be able to explain electric generator AC also. 3, we have done it. It was part of last class homework. Question number 4 is explain the difference of AC generator and DC generator. So the AC generator, whenever we are differentiating, it is in terms of what is the construction and what is the working, how does it work? Because the principle remains same, the parts remain same, but the only difference is the split rings versus full rings. Question number 5 says, which device is used to produce electricity? Describe with a neat diagram. Electric motor, no. Galvanometer, no. Voltmeter, no. Electric motor is used to convert electrical energy into mechanical energy. Galvanometer is used to detect electric current. Voltmeter is used to measure voltage. So none of that. But electric generator is definitely used to generate electricity. And remember that diagram is not given in the textbook. Question number 6, we have already covered. Question number 7, A, B, D, we have covered. And 7C, for electric power transmission, copper or aluminum wire is used. Why? Right? So they are good conductors. So less loss of energy. You can write it on your own. Question number 8, we have completed. Question number 9, we have completed about solenoid. Question number 10B, we had done, which is Fleming's left-hand rule. Question number 10A, we studied in the last class, and this is part of today's homework, 10A. Then question number 11, A and B, we had done it already, fuse and miniature circuit breaker. 11C, you answered it in the class. The diagram is for a DC generator. Question number 12, this is where we started. We completed all the answers, and even I have given you my solutions too. There is a very interesting project at the end, which is under the guidance of your teachers, make a free energy generator. बिना किसी पैसे के energy बना सकते. सोचो, बताओ. If you are interested, we will try to make. With this, we complete this chapter number 4 in Science 1, which is called Effects of Electric